This video is going to cover how to factor a trinomial when there is a greatest common factor. And a greatest common factor is essentially a number or a variable you can put into all of the terms to take it out. And the way I'm going to describe it is undoing distribution. So we're doing the opposite of distribution. We're pulling out the greatest common factor. So you can think of distribution as you normally multiply into a set of parentheses. We're pulling out that thing that we multiplied into the set of parentheses. So we're going to look at our first trinomial, which is 2x squared minus 6x plus 4. And I notice that 2, 6, and 4 are all even numbers, meaning that they're divisible by 2. So the greatest common factor of this problem is 2. So the first thing I'm going to do is I'm going to take the 2 out of all three of those terms. So think about this as doing the opposite of multiplication or the opposite of distribution. So if I pull a 2 out from my 2x squared, I'll be left with x squared. It's just dividing by 2. If I pull the 2 out of negative 6x, I'll be left with negative 3x. And if I pull the 2 out of the 4, I'll be left with a positive 2. So now that I've pulled out my greatest common factor of 2, I'm left with x squared minus 3x plus 2, and that is what I have to factor. So I'm going to put this into my factor square just to keep it organized. My x squared will always go on top, my number will always go on the bottom, and it will add up to the number in the middle, which is negative 3x. And then I just have to figure out what I'm multiplying together. So to get x squared, the side and the top would be x times x, because I'm thinking about it like the area, length times width. So x times x gives me x squared. To get positive 2, I could do 1 times 2 or negative 1 times negative 2. And I'm going to pick negative 1 times negative 2 because negative 1 times negative 2 is going to add up to that negative 3 that I'm looking for. So it doesn't matter where you put your negative 1 and negative 2, just as long as they're there. This is x times negative 1, which is negative 1x, negative 2 times x, which is negative 2x, and negative 1x plus negative 2x adds up to negative 3x, and then obviously negative 2 times negative 1 adds up to, multiplies to positive 2. So our factor of this is x minus 2 times x minus 1. But we have to keep in mind our first step was removing that greatest common factor. So we're going to take it and we're going to put it back in front of our final answer. So our final answer would be 2 times x minus 2, x minus 1. And if you forget to pull out your greatest common factor, you'll still be able to factor this problem. However, the factor solution that you get will just not be fully factored, so it will be incorrect. So it's not impossible to factor it without removing the greatest common factor. It's just incorrect to do it that way. All right, let's try out the next one. In this one, I have 4x squared plus 20x minus 24. And I can see here that I'm going to have a greatest common factor of 4 because all three of those numbers are divisible by 4. So I'm doing the opposite of distributing. I'm pulling out this 4, and I'm going to be left with a x squared from my 4x squared plus a 5x, because 20x divided by 4 is 5x, and then minus 6, because negative 24 divided by 4 is negative 6. So we're doing the opposite of distributing. So if I distributed that 4 back in, I would get the same answer as what I started with. Now I can factor what's left over in my parentheses. So I can put my x squared here, my 5x is what I'm trying to get it to add up to, and my negative 6 down here in the bottom. Of course, to get x squared, we did x and x, and then let's think about the number negative 6. I want to multiply to negative 6, and I want it to add up to a positive 5. So, of course, I'm going to do a negative 1 and a positive 6, because I'll get negative 1x, positive 6x, and it adds up to a positive 5x. So the factor of my parentheses is x minus 1 times x plus 6, or you can do the opposite. You can do x plus 6 times x minus 1. Either way is okay. But I cannot forget to bring down my greatest common factor that I pulled out in my first step of 4. Okay, this last one is definitely going to be the hardest one that we're going to do. And here's why. We're going to pull out a greatest common factor, and then I'm still going to have a coefficient or a number touching one of my x's. So let me show you. We have 6x squared, 28x, and 16. So I'll look at 6 and see if it can go into 28 and 16, which it can't. But what about a smaller number? What about 3? Well, 3 can go into 6, but it can't go into 16, so that one's not going to work. However, they're all even numbers, so 2 will go into all of these. So my greatest common factor here is 2. So I'm going to pull a 2 out of all 3 of these terms. So if I bring my 2 out front, I'll be left with 3x squared. 28 divided by 2 is going to give me 14x, and 16 divided by 2 is going to give me 8. Now, I'm going to try to factor what's left over in the parentheses. So, I'll make my box here, and I'll think about how I'm going to factor this. I need 3x squared, so I need to figure out what I multiply together to get 3x squared. I need my 2 diagonal squares to add up to 14x, and I need my last square to multiply to a positive 8. We are not dealing with any negative numbers here at all. So we're going to look at the number 8 and see what the factors are. We can do, of course, 1 times 8. You could also do 2 times 4. 3 does not go into 8. 4 does, but we already have it listed. And so those are our 2 sets of factors. So this one doesn't have a ton of options. It's going to either be 1 and 8 or 2 and 4. So we're going to start with 3x squared. The first way to get 3x squared is 3x times x. Then I'm going to choose one of my factors. And remember, I want this square and this square to add up to 14x. So whatever I pick, when it goes in those 2 spots, I'm going to need to add it up to 14x. Some of you may be able to see it on your own, but if you're unable to see it, like you have no idea which one to put where, I just want you to start trying things with an eraser in your hand, seeing if it works, and if it doesn't, mark it off and move on to the next one. So I'm going to model this for you. I know the answer right away, but I'm going to show you, if I didn't know what the answer is, how I would work through this. So I'm going to start by using the 1 and 8. I'm just going to put the 1 on top and the 8 on the side, because 1 times 8 is going to give me 8. I want to see if it results in 2 squares adding up to 14x. Well, 1 times 3x would give me 3x, and 8 times x would give me 8x. That 8x plus 3x adds up to 11x, and I want it to add up to 14x, so I know that's not right. But before I say 1 and 8 aren't the correct answer, I want to switch them to the other spots to make sure I try all of the options. So I'll do 3 times 8, which is going to give me 24x, and then 1 times x, which is 1x. Clearly, that does not add up to 14x, so I will say 1 and 8 are clearly not the factors I'm going to be using. Next, I'll try out 2 and 4. So I'll put 2 up here and 4 right here. In the top, I will get 6x, and in the bottom, I'm going to get 4x. And I got 6x by doing 2 times 3x, just to be clear. 6x times 4x gives me 14, does not give me 14x. It gives me 10x, and I want it to give me 14x, so I know that that's not going to work. But I still have one more option. I can switch the 4 and the 2. So I can put the 4 on top and the 2 on the bottom and see what happens. So 3x times 4 is going to give me 12x, and then 2 times x is going to give me 2x. So you can see if I hadn't switched them, I would have missed my answer. I have to try them in both places to see which one works, and you just have to guess and check and work your way through it. So I figured out my factor was 3x plus 2 times x plus 4. But that was the factor of this right here. Remember, I'm trying to factor this whole trinomial here. So my last step is to bring down my greatest common factor of 2 in the front. Okay.